So we're going to start looking at the second part of differentiation today. It involves obviously differentiating exponential and logarithmic functions. And obviously this comes up throughout the different parts of differentiation that we're going to move on to, but I'm just going to use it and apply it with chain rule. I know a couple of you were struggling with what we were doing in terms of chain rule across the last couple of days. So this will give you some extra practice on it, but just bear in mind that the exponential and logarithmic functions, when they're differentiated, it's not just differentiated in terms of the chain rule, it's all that we've learned so far, so I'm just going to apply it to that. So you get a standard table of derivatives, okay, similar to what you got last year. So the first two here are given to you in your formula sheet in the exam. The third one is not, however, it's given as an integral. I'll come to that in a second. Right, when you have a function that's just e to the x, okay, if it's just e to the x, it differentiates as e to the x, okay? The chain rule will come into this, okay, similar to basically what you can see in that third one, but just as I say, it's not given in terms of your formula sheet, but it is just a chain rule, okay? The x, it is a function of a function, okay? As soon as you apply something to the x, so for example, if it was e to the 2x, the x is being multiplied by 2, and then you're finding the exponential of that function. So it's a function of a function. So the chain rule will be applied, and that's what that third line indicates. So be careful with that. But as long as you're thinking in terms of chain rule throughout this, then you won't have any problems. Right, the middle one, if you remember back to what you did in higher, okay, you don't actually differentiate this in higher, but when you have the natural logarithm, that's all ln x is. Okay, so that's a logarithm with base e. Okay, but it's generally we don't really deal with logs in that respect so much in advanced higher. You'll be glad to hear. You generally just see it in terms of ln x. Okay, but what that means is the log of base e of x, and if you want to differentiate that, it just becomes 1 over x. This is important for later on. This is important for integration, because obviously integration is just the reverse of this. Okay, I'll discuss this in more detail later, but you can think caps on why this in reverse is going to be important for later on, and why you didn't necessarily cover it in higher. Okay, so this third one, as I say, is just an application of the chain rule. It's not given in your formula sheet. It is given as an integral, so it's given in reverse. I think it's something like, what is it? It must be e to the ax. When it's integrated, it becomes 1 over a e to the ax. But all that's happening here is it's just a chain rule. So you're differentiating this part, you're differentiating a to x, a times x, sorry, which is just a, and then you're multiplying it by the derivative of the whole thing. So it's just what you're doing in chain rule. I've got an example on it, so I'll show you in a bit more detail. But again, whenever we're doing these different derivatives, you're going to have to think about, is it the chain rule? We've still got product rule and we've still got quotient rule to come. You're going to have to think along those lines too. But again, in the same way that I did the partial fractions, I'll give you some practice of them all at the end so you can see the different applications all at once, because at the end of the day, in an exam, that's what's going to happen. Okay, so just going to go straight into an example, because there's not much more to this than this table. Okay, so I've got it up in the top right there for you to see. Again, this is a different way of writing perhaps the question, okay, but what it means is find the derivative. That's what d by dx means, of 3e to the x squared, okay? So there's lots of different ways of writing it. It could just be find the derivative of the function y equals 3e to the x squared, f of x equals 3e to the x squared. So just keep an eye out. But this is another way of actually writing that question. End of the day, we're just differentiating, okay? But what we've got is we've got an exponential function. And what you should be able to spot is it is the chain rule. The x is being squared, and then we're finding the exponential of that x squared function. Okay, so there's different things applied to that one function. Okay, so it's a function of a function. Okay, so if we set it up like we've set up the chain rule before, so I'm just this is my work, and this is how I like to work it through. If you've got a different way of doing it, it's fine. Okay, but we're basically just splitting it up. Okay, remember what I said, it's almost better to do this backwards. So you've got that function, so look at the x, it's been squared, so that's your first function, that's u. U is going to equal x squared, and then what do you do with that u? Okay, that's the second function. You basically find e to the power of that u function times by 3, okay, so that's your y function. Okay, so y equals 3e to the u, where u equals x squared. Okay, if you substitute that back in, you're just back to where you started, but we're splitting that into those two functions to make our differentiation easier. And that's what the chain rule is. Okay, so we're going to basically differentiate those two functions. So we can differentiate y in terms of u. We We can't differentiate in terms of x anyway because there's not an x there now. Okay, so we're going to find dy by du. Same idea over here. Okay, it's not y, it's u, so we're going to differentiate the u function in terms of x. Okay, so two straightforward enough differentiations. Okay, so the first one, 3eu. Okay, so you're looking up here on this first line. If you've got e to the u, it differentiates e to the u. Because it's 3e to the u, it still just differentiates as 3e to the u. Okay, you can almost just ignore that 3 because it's not applied directly to the u. Okay, you're just multiplying that function e to the u by 3. And when you differentiate e to the u, you get e to the u, so you still just multiply it by 3. Okay, so it becomes 3e to the u. And the x squared, when you differentiate, it just becomes 2x. Okay. So going by the chain rule, what we need to do now is we need to multiply those two functions together. Okay, you don't have to write this every single time. Okay, this is just getting us used to the way this chain rule works. In which case it's just 3eu times by 2x, right? Don't leave your working like that. Okay, you've still got this u, and you actually put this u in the first place. Okay, so we need to take the u out and we need to simplify this a little bit. Okay, so we've got the 3, we've got the 2x, we can multiply them together and get 6x, e to the, and then we substitute our u back in. Okay, so what we should get as our final answer is 6x e to the x squared. Right, you'll notice that this is not that different to what we started with. Okay, we started with the ex squared, we started with a 3, but now we've got a 6x, and you can see all we've multiplied that by is 2x. So there are shortcuts to this. I don't necessarily like telling you the shortcuts, okay, because if you learn the shortcuts, then when it becomes a more difficult question, you're not necessarily going to work out how to do it. But there are very much more straightforward shortcuts to this than writing it all out like this. But as I say, for the more difficult ones, and just for your general understanding just now, it's much better to write it out like this until you kind of spot that shortcut for yourself and get used to it. Okay. All right. So second example. So you might have something like this. Okay. So again, this is a different way of writing it. So find dy by dx if the function y equals ln of x cubed plus 2. Okay. Don't worry too much about what all that means. Okay. You've got most of it in your formula sheet anyway. You've got ln of x. Okay. And you know what the derivative of that is. But again, you do need to spot that this is a chain rule function. We're taking that x, we're cubing it and adding 2. That's the first function. And then we're taking that whole function and we're going to find the natural logarithm of that function. That's why it's a chain rule. And that's why we need to apply the chain rule to our derivative. Okay. So again, same idea as before. You can work this backwards. We've got this x cubed plus 2. That's our first function. That's the first thing that we're doing. We're going to call that u. And then we're going to take that u function and we're going to find the ln of that function. Okay. So y equals ln u, where u equals x cubed plus 2. So we split it up for ourselves and made it much easier in terms of the derivative. Okay, so we are just going to find those two derivatives. We're going to find dy by du, so the derivative of this with respect to u, and the derivative of the u with respect to x. Okay, so using your table, if we have something like ln u, don't worry about the brackets too much here. It will just become 1 over u. Okay, obviously changing out the x for u. Du by dx, so deriving this function, it's just going to be 3x squared plus nothing. Remember, and I think a couple of you get confused when I put these questions in the other day, these are just two totally separate things, and you just differentiate them each individually. This differentiates as 3x squared, this differentiates to nothing. Obviously, if there was an x there, it would be different, but the derivative of that whole thing is just 3x squared. Okay. Right, same as before, if we're finding the overall derivative, if we're finding dy by dx, we need to multiply these two things together. So it's 1 over u times by 3x squared. Okay, and a little bit of simplifying to do here. Okay, obviously when we've got something like this, what's basically happening is we're multiplying fractions, right? Lots of different ways of thinking of it, but don't just, what a lot of people tend to do is multiply the top and the bottom by 3x squared. But if you think of this, 3x squared, it's 3x squared over 1. And if you multiply fractions, you multiply the tops and you multiply the bottoms, in which case it becomes 3x squared over u, and then you substitute the u back in. So this simplified all out is 3x squared over x cubed plus 2. Okay. And again, there are obviously ways of simplifying, doing that with a shortcut. It's just that little bit more complicated. Okay. So you're better off going through this whole process to get to this point. Okay. Right. That's, as I say, that's what we can do just now in terms of exponential and logarithmic differentiation. But we can obviously apply these different rules to the things that we're going to learn in the coming weeks. Okay, so don't think this just applies to chain rule. This will apply to other things as well. This is just the only application we have so far.